Welcome to Maths and Science by IITian. In this lecture, this is the 10th lecture on complex numbers. In this lecture, we will be dealing with complex number to the power of complex number. That means iota to the power of iota, to the power of iota, up to infinity. What is its value? Iota to the power of iota, to the power of iota, up to infinity. It's a very typical question. Let us try to solve it. Let iota to the power of iota to the power of iota up to infinity is equal to x. That implies x is equal to I to the power of x. In the previous class, rather in the previous last two classes, we have seen that e to the power of I into 2 pi k by n represents the roots of unity. And also e to the power of ix is equal to cos x plus I sin x. Then e to the power of I pi by 2 is equal to cos pi by 2 plus I into sin pi by 2. That is equal to cos pi by 2 is 0 plus I into sin pi by 2 is 1. That is equal to I. That means I can be written as e to the power of I pi by 2. Please remember this. And 1 can be written as e to the power of I 2 pi. This also you please remember. Treat it as a homework and prove why it is written so. This I have shown you. This you treat it as a homework. If you put in place of x 2 pi, cos 2 pi is 1, sin 2 pi is 0, I vanishes. Then it will be 1. If it is pi, then cos pi is minus 1. For that we have to go for I into 2 pi for 1 value. For minus 1 value, another homework, represent minus 1 in cos and sin. This also you do it as a homework. Now, here we got the value I is equal to e to the power of I pi by 2. And also x is equal to I to the power of x. Then, can we replace I in this equation? By replacing I value, it represents x is equal to e to the power of I pi by 2 whole to the power of x. Because I to the power of x. I we have represented as e to the power of I pi by 2. Then it will be e to the power of I pi x by 2. The final equation is written as x is equal to e to the power of I pi x by 2. when you consider the for I to the power of I to the power of I up to infinity, if you take this value as x, then x is equal to e to the power of I pi x by 2. Now, taking logs on both sides, what you will get? Taking logs, ln x, natural logarithm, I pi x by 2 into ln e. Ln e to the base e is equal to 1, that is equal to I pi x by 2. The final equation is ln x is equal to I pi x by 2. By taking logs, we get this. Another simplified equation. This represents ln x is equal to I pi x by 2. That is the value. Now, let us use the Lambert's equation. As you already know, x is equal to e to the power of I pi x by 2. Which implies, if you take this I pi x by 2 on the left hand side, what happens? X into e to the power of minus I pi x by 2 is equal to 1. Can we write like this? From this above, using the Lambert's equation, we get the value of x as x is equal to 2I by pi w minus pi I by 2. From this to this, using the Lambert's equation, please treat it as a homework for you. I have explained in the previous classes how Lambert's equation will be used in case of this type of problems and how to apply it. I will give the hint here because mathematics can be understood only by doing. You can take y is equal to, it is a hint I will be giving, y you can take it as minus I pi x by 2, some value y. Then the above equation, x into e to the power of minus I pi x by 2 becomes, is equal to 1 becomes you replace y value here. What is x value? X is equal to 2y by minus I pi, 2y by minus I pi e to the power of y is equal to 1. That implies y into e to the power of y is equal to minus I pi by 2. When here what it is? Y to the power of Ey is equal to y into e to the power of y is equal to minus I pi by 2, which implies from Lambert's equation, it is in the form of the Lambert's equation. Y is equal to W minus I pi by 2. This is the solution. I have done it. And the value of Lambert's equation you can get from any standard values, or it may be given in the examination. Then what is the y value? Y is equal to minus I pi x by 2. From y, what is the x value you will get? X is equal to, y is equal to minus I pi x by 2. Y is equal to minus I pi x by 2. That implies x is equal to minus 2y by I pi. That implies dividing numerator and denominator by I, you will get x is equal to minus 2i y by I square pi. That is equal to 2i y by pi. Then what is the value of y? 2i by pi into w minus I pi by 2. Therefore, x is equal to 2i by pi w minus I pi by 2 is the value of x, where x is equal to I to the power of I to the power of I up to infinity. That means for a power tower of imaginary number I, the value of the power tower of imaginary number I is the value of power tower of imaginary number I will get the value I to the power of I to the power of up to infinity is equal to 2i by pi w minus I pi by 2. This much is sufficient for the examination point of view if w values are not given. If w values are given, then we can find this value as 0.4383 plus 0.3606 I. This is the final value. And this value, it is numerical value. This value You need not worry and worry up to this value. If w minus I pi by 2 value is given, then you can calculate by putting the value of pi. Pi is equal to 3.1416. And w I pi minus I pi is equal to minus I pi by 2. These are only for the academic interest I am giving you. Minus 0.5706, not as a solution. For academic interest, I have given these values to you. And this is the final solution for this problem. Whenever there is a Lambert equation, don't panic. In this procedure, in the way I have explained you how to do it, some y into e to the power of y is equal to some value means y is equal to w of that value. That is a Lambert equation. What is that? Some z into e to the power of z is equal to some x, some value. It is not a variable, some value, let us say p instead of x. It will be more relevant. Then what happens? Z is equal to WP. This is the Lambert equation. Please remember this. You may get questions on this and some very good concepts I have developed in these 10 classes of complex numbers. Please remember them. And these are very, very useful to you. And to find the reason also, I have given you one example how to find the reason of a complex number, the geometrical interpretation. Now, we have done definition of complex numbers, Lambert's equation, addition, subtraction of complex numbers, multiplication, division of complex numbers, multiplication, division of complex numbers, reason, to find the reason of complex number, because complex number is not on a real line. There will be a reason. Within that reason, the complex number either will be open or closed in that interval. It's not like a real number that 1 is less than or equal to x is less than or equal to minus 1. No, it's not like that. Because it's on a plane, we have to define the reason in which complex number is closed or open. Because it's a 2D model. Now, reason of the complex number, it's very, very important. I'll take up one example on reason of the complex number, a typical example, very tough one, maybe we'll take up in the next lecture. Reason of complex. With that, we'll be putting a full stop to the complex algebra. We'll be going to complex calculus. Calculus of the complex numbers. Complex algebra, we'll put a full stop after taking some more examples on complex algebra and complex numbers, and we will move to the differentiation. That is calculus, complex calculus. Then we will go to complex integration. Then we will go to improper integrals in the complex plane. then improper integrals in the real line will be very easy for you. Then reason of the complex number, that I will take 1 or 2 examples on this. It's very, very important. And today we understood, and not only today, for 1 or 2 examples we have developed on power tower of complex numbers. Reason of complex numbers is geometry involved in it. Then after that we will be going for complex calculus. Very important chapter. Once you understand this, this is easy to understand than real calculus. I am telling you. Become perfect in complex calculus, then your integration and differentiation will be easier for you when you go into the real numbers. No, real variables rather. Complex calculus will be taking up next. Reason of complex plane or complex numbers in complex plane, which region they occupy, and how to define the open and closed regions. For real numbers, there will be open and closed intervals of functions. In real numbers it is there, but open and closed regions here. Regions of functions in C, complex plane. These are the regions. Within the open region, within the closed region, this region is closed for the given definition of the complex number, or this region is open, like this. I am not talking about a single number here. I am talking about this is X, this is Y, this is imaginary, this is real, this is imaginary, capital I. There can be a region like this, closed region. There can be a region like this. It's not closed, but it is open. Region is defined this way. In blue color, this is open. Here, region is defined this way. That is closed. We try to define the complex functions, their geometry, and the definitions of the regions in the next class. In the next class, what we will be doing? Complex functions, regions, and geometry. Afterwards, from the functions, we will go to the complex calculus. Please gear up yourself for going deep into the subject of complex numbers, complex analysis. With this, I want to conclude today's class. Thank you for listening to me. Thank you for seeing this lecture. And if value addition has taken place with my videos, please share and subscribe to my channel. Maths and Science by IITian. These complex numbers, complex analysis, complex calculus, all this I will be going in depth. Please pay attention. Please see my previous videos if you have any doubts, and please pay attention so that your real number, real variable, single variable, multivariable calculus will be easier for you, and handling the functions in the real number system will be easier for you. once you are thorough with the complex numbers and complex analysis. Best of luck to you. Thank you for viewing my lecture.